In this video, we're going to work through the practice questions for the trig identities and law of sines and law of cosines. And let's begin with number 1. It says, given that cosine squared x equals 8 over 17, what is sine squared x? Anytime I'm seeing cosine squared x or sine squared x, I want to think about the trig identity sine squared x plus cosine squared x equals 1 and see if there's anything I can do with this. Well, since we're now solving for sine squared x, what about if we plug in for cosine squared x 8 over 17? And the reason I have that idea is because I'm looking at my answer choices. They are in number fractional format. They don't have any trig identities in those. Let's go ahead and plug in for cosine squared x. We're going to plug in 8 over 17, which is what we were given, equals to 1. Now we want to solve for sine squared x. So we're going to subtract 8/17 from both sides, minus 8 over 17. And we could change that 1 to 17 over 17, minus 8 over 17. That gives us 9 over 17, or you could have plugged that into your calculator. And that is answer choice D, 9/17. Taking a look at number 2, it says for x such that 0 is less than x is less than pi over 2, the expression square root of 1 minus sine squared x over cosine x minus the square root of 1 minus cosine squared x over sine x is equivalent to, and then we have these different answer choices. So we're looking in values of x from 0 to pi over 2. And just as a reminder, if we're thinking about where that is on our, if we're looking at a unit circle, when we're going from 0 to pi over 2, we're talking about this section right here in quadrant 1. That's what we're looking at. So again, like I had stated previously, anytime I'm seeing sine squared x or cosine squared x, I want to think about our identity sine squared x plus cosine squared x equals 1 and see if we can utilize that. Because we have two different things we could branch off of here, we know using this equation that sine squared x is equal to 1 minus cosine squared x. I just subtracted cosine squared x over here. But we also know that cosine squared x is equal to 1 minus sine squared x. I just put this one equation in two different formats. I solved for two different things. Now, these should look familiar. The right-hand sides over here should look familiar to what we have underneath our radicals. So let's do some substitution. We have 1 minus sine squared x. Well, that is equal to cosine squared x. So we have the square root of cosine squared x over cosine x minus the square root of, we have 1 minus cosine squared x. That is equal to sine squared x divided by sine x. And now we can take the square root of each of these terms in the numerator because it's the same thing as if we had the square root of 2 squared. That's just equal to 2 because under the radical we're looking at what two items we can multiply together that would make a perfect square. So we're going to be able to pull out cosine x out of this first term, and that's cosine x over cosine x minus the square root of sine squared x is just sine x over sine x. And when we simplify here, this is going to go to 1, this goes to 1, and this just turns out to be 1 minus 1, which is equal to 0. And that is answer choice F. Number 3 says, given the measures in triangle ABC below, and that angle B is equal to 87 degrees, and I'm going to go ahead and write that in, 87 degrees. Which of the following is the length in inches of AC? So we're looking for this length right here, AC, and it looks like we're already given that BC is equal to 8 and AB is equal to 10. So we have those. Now normally if we knew that we had a right triangle and if we had two side lengths and needed a third, we would make use of the Pythagorean theorem. But we can only do that because we had a right triangle. We have an 87 degree and these other two, we're not told that either of these other two angles are 90 degrees, so we cannot assume that. So we're going to make use of either a law of sine or law of cosines. The way that we can determine which one we're going to use depends on what data that we are given. We are looking for the side length x, and we have the angle opposite that, and then we have these two other side lengths, but we don't have any other angle measures. To be able to use the law of sines, we would need at least one other angle measure that we could use to set up our proportion for the law of sines. So it looks like we're going to need to use the law of cosines here. And we can kind of get a hint by looking at our answer choices here. I would be familiar with the law of cosines and the law of sines. Sometimes they give it to us. In this particular case, they did not. But since we are looking for this side length x, what we normally do, that is going to be equal to x squared, and then we have our other two side lengths, 10 squared plus 8 squared, minus, then we take our 2 times, that's part of the formula, 10 times 8, those two side lengths, cosine of the angle opposite the side we're looking for. So that would be cosine of 87 degrees. This is our formula. And it comes, you could look that one up to get the exact formula. I'll write it here. So if we are looking for side length C, we'll say C squared is equal to A squared plus B squared minus 2AB cosine of C. And you can substitute in your A or B values, whatever, given the side lengths that you're given. Okay, so we don't even really have to plug this into our calculator because these are not worked out that way. They're just showing the numbers being plugged in. Everything looks very familiar right here. The only difference is they're doing the square root, and that's because we're solving for that unknown. So we take the square root of both sides, giving us x equal to this square root of all these terms here that we have plugged in. And so that makes answer choice E the correct answer. So be familiar with our formulas just in case they don't give them to us, just enough that we can pick out what we're looking at usually in the answer choices. So number 4 says if a surveyor took and recorded measurements as shown in the figure below, which of the following would be the most directly applicable for the surveyor to use if she wants to use these 3 measures to calculate the length of the reef? And so she's looking for this value, this length of the reef. We have a side length here of 2245, a side length on this side, and then we have the angle that is opposite the length of the reef. So now if we may read the question and not quite understand what we're looking for, let's see if the answer choices can help us figure out what we need here. It asks which of the following would be most directly applicable. What does the surveyor need to calculate the length of the reef, that third length of that triangle? Would the surveyor need a formula for the area of the triangle? Well, no, because area is talking about the inside. That doesn't help us necessarily find this length if we don't have a couple of other things that we need. The Pythagorean theorem, we talked about that previously. That only applies when we're talking about a right triangle and we're not given any indication that we have a right triangle here. The ratios of the side lengths of a 45, 45, 90 triangle. Well, again, we have no indication that we have a 45, 45, 90. In fact, one of our triangle lengths is 55, so that one's going to be out. So we're left with answer choices J and K, which look like the law of sines and the law of cosines. So basically, we need to figure out which one of these laws would help us to solve to find this length. And like we talked about in the previous question, when we have the angle that's opposite the unknown, and we have 2 other side lengths without any other angle measures, that's going to default to us needing to make use of the law of cosines. That's answer choice K. We look at the data that we're given and we see which one of these formulas, which one of the laws that we can apply and use to solve for whatever missing information that we're needing. Now we'll take a look at question number 5. It says in triangle ABC, what is the expression for the length of BC? So we're looking for this length of BC. And let's look at what we're already given. Looks like we're given 2 angle measures. We are not given the angle measure opposite the unknown length, but because we know that the angles of a triangle add up to 180, then we're given 2 angle measures, we could find the third measure, angle A. We can find that. We'll see if we need it. We are given the side length of 15, which does have its angle opposite. So we're set up a little differently than the previous problems that we were looking at, where we were given side lengths and then maybe just 1 angle measure. So looking at our answer choices, it looks like we're going to make use of the law of sines just based on what all we see here. And if you'll remember, for the law of sines, we want to be familiar with these enough that we can say they are similar to, if we're looking for side length A over sine A is equal to side length B over sine B equal to C over sine C. Or you could have written this with the sign on top. It doesn't matter. As long as we're consistent that we have the side lengths in the numerator or all across in the denominator, we can flip them. We can look at the reciprocals. Let's take a look. If we're looking for our unknown, which we'll just call this side length X, let's go ahead and figure out what angle A is equal to. And it is equal to 180 minus 55 minus 38. And that is equal to 87. And so when we put that in, that will be 87 degrees right there. Now we can make use of our law of sines here. And so we're going to say side length X over sine of 87 is equal to, since we're given this length of 15, we need to use the angle that's opposite it, which is sine of 38. And so that gets our proportion set up that we can now solve for X. So to figure out what X is, we need to multiply both sides by sine of 87. And that's still divided by sine of 38. And we're keeping an eye on our answer choices because we're not having to plug these values in the calculator. It looks like they're still using the sine. So where do we have 15 sine 87 over sine 38? That's answer choice B.